Hey Imran, how are you?
I'm good. How are you?
Not too bad, man. Not too bad. Cold today, but you're back to Canada, or are you still in? You're still back home?
I'm back to Canada.
Oh,
It's
okay, very good, very good, very good.
been a week
So
or
you came
so.
back to the well, then you came back to the nice cold weather now, eh?
It is storms and everything.
Oh man, I know, man. It's too cold. It's like -22, I think, when I just drove to the center today. So it's getting there.
Yes.
Yeah. Okay. All right. Let's get started. So I know in today's lesson we're gonna look at how to create something called static route or RIP protocol from Cisco. This is how you remember in last class we had a look at how to configure one router and send information across from different computers and different network. But in some cases, one router is never the same. It's never one router. You always have multiple router among floors or among different facility itself. So you need to create something called a static route or RIP protocol. So we're going to look how to get that configured. So pretty much the setup what we're going to work on, it'll look something like this. I'll show you what it would look like. So right now, today's class, we're going to see how to create three routers with three different networks. Imagine one is going to be like Ontario, one is going to be BC, one is going to be like Nova Scotia. How are we going to actually connect them? What type of connection they'll require? How do we actually program them so they can all talk to each other from a different network? Okay. And we're going to look at this from scratch. Okay. Just give me 1 second. Let me get started on this one. Second. Okay. Let me open up a fresh packet tracer here. And I can just this. All right. So in this scenario, we're gonna have is three different networks. One is called Ontario. I'm gonna put a just a name in here. Ontario and Ontario's network for connection. We'll look at it just a little later on, and We're gonna have one more called uh, BC, and we're gonna have something called Newfoundland. Okay. So each one of those will have its own router. So what I'm going to do is I'm going to get the 1841 router here. Okay. And then what I'm going to do is I'm going to create a switch as well. I'm just going to get a typical switch here. And then I'm going to put in some end devices, couple. Okay. So now let's get them connected. So we're going to go into the connectors. Then, oh, okay. So I'm going to just choose a copper straight through cable, connect the PC first. And I always like to leave the first Ethernet port for the router connection. I'm just going to start from number 2, connect this 2, and then this one will be number 3, okay? I'll go for these PC as well. 3. Okay, now we got the PCs and everything hooked up. All right, now let's get the routers hooked up, okay? From number 1, and I'm going to connect to fast Ethernet 00. Do the same thing here, fast Ethernet 00 to fast Ethernet 1. Same thing here as well, FS01. Okay, now we have individual routers connected, and let's give it a network ID, which we're going to use for these things. So I'm going to make sure here this is going 192.168.1.0 network. Okay, let's do that. And then this one is going to be 192.168.2.0 network, 2.0 network. And this one is going to be 192.168.3.0 network. Okay. And we're going to make a connection for these. So what we're going to do is we're going to make sure to go into the computers, and let's just set the computers up as statics itself. Okay, let's go to desktop, go into IP, and we just have to give it the same as, this now same and in the network range, right? So we're going to give the router 192.168.3.1, right? So that will be the first starting IP address that we should be assigning to the router. So in this case, for the desktop, or for one of the desktop, we'll give it 192.168.3.2. And then the default gateway will be the same IP address as a router, right? 3.1. That'll be a router's IP address, okay? This one, let's go here. 192.168.3. I'm going to do 3, okay? 3.3.1. Now let's do the same thing to here. 92.168.2.2. Oh, sorry, 2.3. That's the other one, right? 192.168.2.1. Okay, because this is a 2 network, right? 92.168.2.2. 2.168.2.1, the router's address. It's 8.1.2. Okay. This one would be 192.168.1.2. Oh, sorry. 192.168.1.3. 68.1.1. Okay. So now we know that these computer already has a static IP address. We know what we need to set these routers up, right? So let's go into the router. I'm just going to do no. Okay. So Imran, I'm going to ask you, what do you think the first thing that we need to do to set these up? Just these individual networks. Let's worry about that first. Let's set BC up first.
We initialize the router with the name.
Mhm.
And
I'm going to do host name, and I'm going to do as BC. Yeah.
And then we will give the network IP like 192.168.0.1.0.
We would do
Or
1.1, right? Yeah, very good. Yeah.
1.1.
Yeah, very good, very good. So which port should I be doing that? And how should I be doing that?
Mm.
That's okay. This is connected to FA00. Okay, here. Can you? It might be too. Let me try zooming in. Yeah, there you go. Ah, yeah, this is a lot better for you then. This gives you what port number is connected here and what port number is connected here. Okay.
That will be port 0 for
Yeah, FA000, right?
yes.
Interface FA0/0. Okay. Now, what command should I be doing here?
Um,
It's okay. There's no right or wrong, man.
um,
It'll be IP
IP.
address 192.168.1.1, right?
Yes.
And then
And then uh, then we tell like how many ports we have on this /24
um
or whatever kind of like on this router. No.
no. So what we do subnet mask, right?
Mm.
So what will be the subnet mask for this?
Oh, 255.255.20.
Very good. And then enter. Okay. Now we have assigned, so we have told anything in this port is connected to is going to be on the 192.168.1.0 network, but we have assigned 192.168.1.1, the first available IP address to this port, right? So next, what should we be doing?
Um,
No shut, right? Remember these ports are
no,
turned off.
no shutdown. No
Yeah,
shut.
yeah, very good, very good. No shut. So it's changed to up, and you're going to see this changing to up. Okay, very good. Give it a second; it'll turn on. Okay. Now let's do the other ones too. While that's getting turned on. Okay. Let me scroll down here. Okay, and I'm gonna just do no. And Imran, you're gonna just tell me what commands I should be doing here.
Mm.
Enable, and then conf ft.
Will con and then configuration.
Yeah, configuration terminal, and then we're just gonna do the host name first. Okay, let's do the host name. I'm gonna do Ontario.
Then IP address.
Okay. But before that, we need to do something. We need to. You're gonna put the IP address in, but you need to say where you're gonna put the IP address in, right?
Right. So it will be a FA0/0.
So can I just put FA0, or should I be putting something in before it?
No, there should be something before it.
Yeah, it should be interface. Okay, interface FA0/0. So because then you're going to the interface of FA0/0, and then you're gonna do IP address 192.168.2.1, and then 255.255.255.0. So if it's a 255.255.255.0, how many nodes can we connect to it, Imran?
254.
Very good, very good. Yes, that's correct. Because one gets burnt away for broadcast, right?
Yeah.
Technically speaking, I think it's 253, right? I believe it's 253 because we are
One
using
is
the first of,
broadcast.
yeah, one is for broadcast and one is for network already been burned. So because we already used 2.1, right? This has been already burnt. And the 255 has already been burnt, right? So I think 253, right? Technically speaking, like the correct is 254 /24 network. Sorry, I just want to. Oh no, you're right. 254. That's it. Yeah, yeah. It's 256 originally, and it's two burns away. One is for network, one is for broadcast. Yeah, yeah. You're right. Sorry. Very good. Okay, perfect. And then we'll just do no shut here. Now this is now configured. Okay. Now what we'll do is we'll go to the same thing here, Newfoundland. I'll just do no. Enable.
Enable host name.
Then host name.
Newfoundland.
Newfoundland.
And then interface.
Give me 1 second. I can't. I seems to be. I'm having some issues seeing. It's too small for my eyes. Okay, that's okay. Perfect. And the interface FA0/0, right? With an
Yes.
IP address
168 3 dot one
192.168.3.1, and then 255.255.255.0.
0.
Okay,
And then
perfect.
no
And then
no
no
shutdown.
shut. Perfect. Okay. Now let's Janisha, welcome to the class. Sorry. So what we'll do is okay. Now let's test if the computers can ping the router itself. Okay. So let's go here and let's go to command prompt and do ping 192.168.1.1, right? It should ping a router, which it is. Okay. Perfect. But if we try to ping the other one, the anterior one from BC, the 168.2.1, what do you think will happen?
It won't because there's no connection in
Very
between.
good. Yes. Yes. Very good. And let's do a connection. Okay. So let's say if we were to do copper connection here, there's fast Ethernet 0, 1, and then if we go back here, there's fast Ethernet 0, 1, right? That's one connection, but we cannot connect. You see here, there's no more connection available left here, right? It's all done. So in that case, what we can do is this. Usually routers, we can add in another extra port. So let's do that here. Give me 1 second. So let's go into, oh, sorry, I want to do that. Let's go into the router first. And let's go to end, END, and let's do write to memory. Because what we're going to do is we're going to shut down the router, okay? I'm just saving this to the memory, and I'm going to go to the physical and go here and shut it down. Now, what we're going to do is this. We're going to shut these routers down first, and I'll show you. I'm going to write this to the memory, or you will lose the configuration, okay? I'll shut this down because we're going to add in another port into it. And okay, I want to end this. So we can add something called serial connections that allow us to communicate between routers. It's the most stable and most viable connection which we can do, and it is part of WIC2T. This connection here. This is the dual serial port WAN interface card, features Cisco's new compact high density smart serial connector to support wide variety of electrical interference. When using with the appropriate transmission code, two cables are required to support the two port on the WIC. And this allows you to do a router-to-router connection with the most stable and most, um, and you can say at what frequency and what speed that each port can talk to. Usually, it's recommended to leave it to automatic. On the older router of Cisco's, you can actually set the transmission speed to make sure it matches. It's called DTE and DCE options. Okay. So once you have turned this off, and you have selected WIC here, WIC-2T, you're gonna see this over here. You can just drag this and drop it here, and it's just like physically doing this, right? That's what it simulates. So if you're adding actual port, so you just went in and added in here, okay? And then I'm gonna go ahead and turn this on, and I'm gonna do the same thing for the other ones too, okay? Same thing. Turn this on. Turn this on. We're gonna see that the router is starting to boot up here. Okay, it's booting up. Now let's make another connection here, okay? And this is called a serial DTE connection over here, serial connection, okay? Let's click this one, not the one with the timing, not the serial DCE. It's called serial DTE. I'm going to click on this, click over here, and I'm going to do the first one. Is going to be serial 0/0/0, and then connect to Ontario to serial /0/0. Okay. And I'm going to do one more. I'm going to do this one again, and I'm going to do serial 0/0/1. And just to match the theme, I'm going to do the same thing over here to the one. Okay, but you can do the 0 here too. It doesn't really matter. So what this is going to do is it's going to allow a connection between those routers. Okay. Now, if I was to ping from here, now we have connections to these routers. What do you think will happen if I try to ping that 2.192.168.2.1? Let's try this faster one. So the packet's leaving from this. Just moving this around so you guys can see. So what's happening here is your computer is trying to reach 192.168.2.1, which is this network over here on this router, this port, right? It seems like it can go somewhere, but it cannot reach it. It's like, trying to send a letter to an address that does not exist. The mailman will still take it, but it just doesn't reach the destination. That's why you get destination host unreachable. Okay, which means we need to tell the router where these are located, at which port, where they're located. So the routers can easily tell, okay, this network is, I know where this network is, I can forward it off. And each router should have these records in them, okay? And they're called the routing table protocol. And we're going to create a routing table, okay? And it's called a RIP protocol, okay? And this is something that it's easy to configure. I'll show you guys how to do it. And you guys will be having a assignment part of this class as well, where you guys be creating this on a multi-layer, like at least on a five different routers to make this same multi-routers. Okay, so now let's go into the thing over here. Let me just move this up so you guys can see the port number here. The port number is important too, but for this to work, right, we need to give these ports as well IP address. Okay. Oh shit, sorry. Okay, so we need to give these ports 0/0/0/0, and the port over here and over here IP address as well. Okay, and it must be the same network here, these connection. So let's go here and let's give this the 10.0.0.0 network. Okay, over here, and then over here, and this will be a different network, right? This will, let's give it as 11.0.0.0 network. Okay, so that's the network between these. Does that make sense, guys? Do you guys understand why we're doing this? So these ports can communicate with each other, okay? And any questions so far?
Yes, in a network, we're giving a router to a network address like 192.168.1, which is a network part. But when we are giving a port a network address, I don't understand why
Okay,
it is
so
working.
Okay, and just to reiterate what you said, if Imran, just correct me if I'm wrong. Okay, so you're asking, okay, I understand that this is having a 192.168.1.0 network address, but why are we assigned to a port? Is it the question?
Yes.
Okay, yes. So on a commercial router, right? Each port can have its own networks. So we can actually assign a network to a port itself. And usually it's done on a port level. So if you have several ports, like if you have 3 or 4 ports, you can actually have different networks connected to each one of them. And then they get connected to a switch. A switch will have multiple, inputs and outputs, right? Like you're like if you think about it in a home environment, you only have one router, you have only one network, right? You don't need to do multi-networking in there. But in a corporate environment, a router must be capable of doing several different networks as long as it has an amount of ports available. The switch is just dumb, right? At the end of the day, switch does not have any IP address. It's just dumb. As long as it's connected to the port that's assigned this network, it will just forward that to it, to everything that's down connected to it. And in the switch, you can connect access points. You can connect your cell phones. I mean, your landline phones, and pretty much anything that connects to a switch, right? It gets the same network.
But the router is different thing. Router has this network address 192.168.1,
That
and
zero,
port can have a separate network. This is what
yeah,
you mean.
exactly. So a port can have each port can have separate network, or the router can be assigned to the router can be assigned to one network for all the ports, or separate network for each port as well. Yes, you're right.
Okay.
Uh, yeah. It's but usually on a corporate level, we assign if it has to. Usually, a router will have only 2 ports. Sorry, 3 ports in real. One is the input port from the modem itself. This is where the ISP's modem will come in and connect, and the 2 other ports is for you to create any other network you like, and have a space for you to add expansion card if you ever need to add more of these ports. But defaultly comes with only 3 ports. One is for input from your ISP modem, and 2 is for creating any 2 additional network. And what you will do is one will be for DMZ, demilitarized zone network. We'll learn a little bit more about it too. It's more like if you want to create a network for anyone to connect, it's a guest network type of thing, right? So that's what it's used for. Or you can use that for another ISP input. So let's say you want to have a setup where you have one modem from Rogers and one modem from Bell or Starlink, and suppose one goes down, you want the other one to kick in, you can set them up as a redundancy as well. Okay.
Okay.
Does that answer your question, Imran?
Yes.
Okay, perfect. Yes. Yeah. So now we want the 2 different routers. Remember, we want the Ontario routers to talk to BC routers, and then we want to make sure the BC router can see Newfoundland router as well, right? And vice versa. So it should be like everywhere should be able to communicate to everywhere within this network itself. Okay. So now we're gonna have to give these ports a number so they can allow communication. Okay. So now let's do that too. Let's go here and let's do enable conf ft, and same process as how we done for interface. We're just going to do interface serial 0/0/0, and we're going to do IP address. We're going to do 10.0.0.1, and because this is a class A IP address, we're going to give the 255.0.0.0. Okay, and then no shut, not no shit, no shut. And this is at 10.0.0.1, a class A network, which is going to be 255.0.0.0, and no shut. And I'm going to do the same network for the 0/0/0 port as well. Okay. So I'm going to do enable conf ft, and then what I'm going to do is I'm going to do interface serial 0/0/0 IP address 10.0.0.2. And then I'm going to do 255.0.0.0. Okay. Because This port is on 10.0.0.1. This port should be 10.0.0.2 because they're on both same network. And then no shut. Now we have enabled communication between these two routers. And how do you think we can verify it? Can we, if we can actually test the connection between the Ontario and BC? The easiest thing we can do is ping this port's IP address. Remember the serial 0/0 for the BC? What do we set that up as, guys? Ping 10.0.0.1, right? Remember? Perfect. Now, do you see this is 100%? So now we can see the connection between here to here is working. Now let's test if we have the connection between this 10.0.0.2 to 192.168.1.1 to this port over here, okay? 192.168.1.1. Okay, 0%. So still, the Ontario router cannot see the 192.168.1.1 or 1.0 network here. It's because it just does not have it in its purview. Remember, the 10 dot network is in a different universe itself, right? It's in the 2.255.0.0.0 universe. It's talk about a universe. So it has no purview to see where is 192.168.1.1. It just doesn't, it's too small for it, so it doesn't see it. But we can tell how to look for it, okay? Now let's configure each one of those places so we can ping each other, and then we'll talk about different networks, okay? Now we're on the Ontario router, right? Now, if you see here, the Ontario is a middleman for Newfoundland and BC, which means we need to configure the serial port 0/1. So I'm going to do enable conf fp, and then I'm going to do interface serial 0/0/1. Right? And remember, we assigned 11.0.0 network here, right? I'm going to do IP address 11.0.0.1 255.0.0.0. No shut. Okay. Go back to here, Newfoundland, and let's configure that too. Enable conf-ft interface serial 0/0/1, because remember we did 1, right? No shut. Oh, sorry. IP address 11.0.0.2 space 255.0.0.0. No shut. And I'm going to do end and then write to memory. Okay. Let's try pinging the other port, which is 11.0.0.1. Perfect. So the Newfoundland port can see this 11.0.0.1. This router's end port, and these end ports can see each other. Now, if we even try to ping the 10 dot, the other side, 10 dot on the same router itself, different port, okay? So what we're going to do is we're going to do 10.0.0.2. It still cannot see it because all it sees are the two end devices. That's all. You can see that Ontario's one side is facing, it can see, and Newfoundland's router can see. Newfoundland router can see the port number up to here, the S0001, which is a good sign now. Because now we know these are connected. We just have to make something called routes to make sure it goes through it, okay? That's all we need to do. So this Newfoundland can see from here to here. That's all you can see. This router can see this portion. This router can see this portion. But still, these are still on a separate island itself because they're on a separate network, right? So we need to enable them so they can communicate with all of them. Okay, that's all you can do work. Now let's take a look at what we need to do to configure these type of things. Okay, we need to understand our network IDs, our network addresses. Okay, can you guys tell me how many network addresses we have here?
We have about 6 networks.
Six, six, five, right? One, two, three, four, five, right? Maybe
Uh,
you're seeing.
yes.
Yes, maybe you're just counting
Uh,
something wrong. Yeah, I think you're counting this thing. Maybe thought it's a number. Maybe you thought this was a number. No, no, no. It's small. I know. I understand. No worries. It's one, two, three, four, five. Right? We have five different networks. Okay. And the more complex system you build, the more network you have. But as long as you understand these are the things that you need to specify the network, and you need to specify everything that must be reachable. Okay. And in a real corporate environment, not everything needs to be reachable. That's the thing you need to understand. Okay. Not everything needs to be reachable. So let's make sure we create something so this PC can talk to this PC as well, and vice versa. And all of them has communication. Okay. So let's go into our BC first over here, and I'm just going to do exit. I'm going to be in the configuration mode. Okay, over here. I'm going to type in. It's called router RIP, RIP, and it's a protocol where we can say where these networks are. What are the network I should be able to see in my environment and in my universe itself. So I'm going to do network, and I'm going to start listing out all the networks that I should be seeing. Okay. Let's say we have 192.168.1.0 network 2.0 3.0. We're just going to give the network IDs, okay? Because we want to make sure everything in the network gets included, okay? And then we shouldn't forget to include these connection IP addresses too, right? Networks too. So we're going to do 10.0.0.0, and then we're going to do 11.0.0.0 as well, okay? Now we have done this. Now, if I was to do ping 192.168.3.0, sorry, okay, 3. I know what I'm doing wrong. Oh, .3.1. See, I'm in the BC router, right? I'm trying to ping the 3.1, which is this router over here, this port over here. It's still gonna be at 0%. The reason is because remember, we only told BC where is Newfoundland located, right? The BC still needs to pass through Ontario for it to give it information about Newfoundland and vice versa, right? So we need to configure this on every routers that's going to be interacting with it, right? So let's configure Ontario as well. And it's the same configuration method, okay? I'm just going to do end, enable, conf-ft. We want to do, what is the command, guys?
Command for telling about the network.
Yeah, the router command, yeah. To set up the static routes.
Like we gave the last time, say
Yeah,
network and all
yes.
the 192.168.1.
Y-
It was network.
We need to do router RIP
Oh,
first, okay?
so router
Router
RIP
RIP.
and then network.
And then network, yeah, very good. And then we're going to do the same thing here. It doesn't matter about the order, guys, okay? It just matter as long as the network is there, it's there. I'm just going to do 0.1. I'm just going to do 2.0, 3.0, and then we're going to do 10.0.0.0. Okay. So now we're in Ontario, we created it. So if we were to ping from the Ontario to the 192.168.1.0, second, ping 192.168.1.1, we should have a clear ping because now we have specified it, right? And the same thing will happen if we, because remember we tried doing pinging the 3.1 here, right? It failed. But if we do the 2.1, this should pass. It's because BC and Ontario knows where each of the network is located. BC is telling, okay, this is where I need to go to Ontario. Ontario knows where to point it out to them too, okay? So now, if we were to do the same thing for 3.1, it doesn't know because Ontario does not know. Ontario knows still it exists, but BC is still not gonna. I mean, Newfoundland's not gonna pass it over, right? So it's gonna fail 100%. So let's do the same thing in the Newfoundland as well, okay? Genesia?
Yes, sir.
Hey, yes. So in this one, let's do what command should we be doing here? So let's set up the network route. Okay, I'm just it's okay, I'm just playing. I hope everything is okay with you. Okay, not a problem at all. So it'll be router RIP.
Right.
Okay, and then you'll do all the networks from here. Okay, so let's do network 192.168.1.0, and then let's do the same thing for 2.0, and let's do the same thing for 3.0, and then let's do 10.0.0.0, and then we're going to do 11.0.0. Now, if we were to ping, let's do end. Sorry, end. If we do ping 192.168.1.1, the ping should go through 100% success rate. Okay. And then if we go here, remember what we tried here? This failed. The last one failed, right? It's 0%. If we were to do the same thing, it should be 100% because now we have told where it should go. So now we have full network connectivity. And let's go here into PC. Let's go in our end device, go into our command prompt. The 2.1 loss, right? Remember last time we tried it? Let's try it one more time now. Remember, sometimes the first one will fail is because for you to find out the information, right? But it should go through the next one. And I'm going to do 3.1. It's this end over here, right? And we should be able to ping all the computers as well. 3.3. Remember, we set this computer up as 3.3. The first one might fail, as I said. It's trying to figure out the best route. See, the first one failed. And the next three are pass, okay? Now, if you do the same thing again, you should have all four of them pass. Because it has found the way and has saved it. If we wanted to see it in the simulation environment, let's go here and do this PC over here, which is dot two, 3.2. Let's put this. And this is exactly what's happening in real life network when these trying to ping and trying to communicate right between each other networks. Okay. So you can now see that how this real life scenario works on for pings. Okay. So what you guys are gonna do is I'm gonna give you guys a small class activity where you guys will be. Do you guys have Packet Tracer installed on your computer?
Yes.
Okay, perfect. Now, what you guys gonna do is you guys gonna create the same thing again in your Packet Tracer, but you're gonna add a fourth router in it. Okay, so you're gonna have total of four routers in it. Okay, and so you have four different networks. And I want to be able to see when you guys share your screen the from PC 0. So you'll have one, two. This is what for six. You'll have eight computers, and from any point of the network, we should be able to ping any of the computers. Okay. So any of the computers should be able to ping any of the computers, and it should be in a different networks. Does that make sense, guys? But you're gonna have an additional router. It's not gonna be three routers. You're gonna have four routers. Okay. So
Okay.
in terms, you should have one, two, three, four, five, six, seven different networks. Okay, you should have. You'll have seven different networks. You will have to have another port added on, like the physical one. Just to give you guys a tip, you guys can add another port here and drag it and drop in here. Okay, you won't be able to put it in when the power is turned on. Okay. And can you guys will you guys be able to do this by end of class today, or do you guys want to have time to do it so you guys can have 1 week to do it before the class starts next class?
Whatever you decide.
Yeah, I think this should be, you guys should have enough time to complete this. So let's say, before the start of next class, like 1 day before the start of next class, it'll be due. So what we'll do is we'll have a review during class time. Okay. So I'll give you guys small documents then of what network expectation we have. So let's say this. Okay. Let's devise a small let's divide a small thing. So we're gonna have BC, Ontario, Newfoundland, and Montreal. Each one of this should have a router, switch, to PC. Okay. And this one should be on the network of 192.168.1.0, and it should be a /24. And the connection should be in the 10.0.0.0 network for this to this. Um, and you'll also have 11.0.0.0 because yeah, and then 0. And the PC, you just have to give them the appropriate PC IP address. But this is what your network's thing should be. Your network addresses should be. So there's one, two, three. Sorry, one, two, three, four, five, six, seven, eight. What the hell? I'm confused. Hold on. One, two, three, four, five. There's a 10 different networks in here. Okay, 10 different networks. Does this make sense, guys? And I'll don't worry. I'll put this in your LMS. Okay, so you can go and take it off of this one, this network, and design it. And I want you to be creative. You can add as much PC as you like. If you want to add two different switches, you can. The next class, what we're going to do is once we complete this, we're going to take your assignment and see what we can do to add more switches and more complications, so we can do some rules and blocks. Okay, that's what we're going to look at next class. But this is going to be important for you guys to set up so we can start working on next class. Okay. Do you guys have any questions about this setup?
Yeah, just to clear up,
Mhm.
when we are doing the interface serial setup, so as we have over here 10.0.0.0, that's one network we given to the router, and 11.0.0.0 is we are setting up on the serial uh, home.
Uh, oh, okay. So think of it this way. You know how for Ontario, right? We are so when I say two different networks, think of the same thing here. So remember for the Ontario router here, I'll show you a show interface brief. Show this. Okay. So if you see here, right, Imran? So this 0/0, this port over here is on the 10.0.0.2, right? And this serial one is in 11.0.0.1. Like it's assigned to each one of these ports, the
Yes,
ports.
that's clear.
Yeah. And so where it connects. So that's the reason why I wrote like this. So you'll need to make this. So just to give you guys a hint here, I'll show you guys 1 second. Where is this? This is yes. Let me just save this 1 second. Okay. So let's say this. And I want you guys to use a router 1841. Okay. Let's see if we do this, and then I don't want to show you guys too much because I want you guys to do a little bit of struggling around. Okay. So let's go ahead and turn this off first so we can add in more ports. Oh, sorry, this is the wrong port. Let's see. So here, I want to turn this on. Go to the second one because I know these two going to have two different ports, right? Because they're going to be connected through here and they're going to be connected through here. They need two available ports. So I'm going to go here. This. Okay. Now, how this will work is this. So let's say if I do 0 here to 0, and if I was to do 1, I'm going to do 1. I'm going to do 0 to 0 here, right? So this is what a 4 network will look like. So you'll need to assign to each of these ports over here. The S00 will be same network as this. This two should be, these S00 ports should be the same. This S1 and this S1 over here, we can't see it because the labels are overlapping, but yeah, it's coming through S001. So this S1 and this S1 should be on the same network itself, and this should be on the same network. Okay. Does that make
Okay.
sense?
Yeah.
And it should be assigned to the port itself. Yeah. The appropriate port. Sorry, it will not work. Okay. I'll put this on the I'll put this thing on the this requirement on the LMS itself right now, and I'll it should be in the LMS in about 5-10 minutes. Okay. And once the video is recorded, it should be done. It should be uploaded within today, within the next couple hours. Okay, for you guys in the LMS for this, so you guys can go ahead and watch this and do the assignment. And please, once you're done, just save the packet tracer. You guys can save the packet tracer file, save as, and save it with your name, and just email it to me. Okay, you guys have my email, right? So that way I can take a look at it, and if there's any correction we needed, I can tell you guys right there. Okay. But what I'll do is this. I'll right now post this on. How did you guys find the routing tables, setting up routing tables today? Was it easy? Was it a bit complicated? Was it confusing?
It was very easy. It's the only thing,
Easier.
like past 1-2 week, I was not able to focus on it because
Yes.
was busy
You're
in night.
traveling, right? Yeah.
Yeah.
Yeah, completely, man. I understand. Yeah, traveling is the most headache, right? Especially when you're coming from like these long flights. Oh my God. It takes time to adjust to the time zones.
Yeah.
Give me 1 second. I'm just posting this on the. Okay, I just posted under February 1 on our LMS itself. Okay, you guys should be able to go and pick it up from there. Okay, perfect, guys. Any other questions?
Yes.
Okay.
When we have like multiple networks, we're connecting just like this one.
Yeah. Yeah.
So there's the central network, central network controller. So can
Okay.
we force all this network information from one controller to all our devices, so we don't have to go and change every time
You
we are
can.
putting one? Yeah.
We will definitely look at it. It's called network automation. So we can have all the router in sync and just send all the information to be updated throughout the routers. For sure. That's part of
Okay.
network automation. Yes. We will look at it to, because the CCNA exam will need you to understand network automation to an extent. You don't need to be master at it, but you need to know how the network automation works, how to have a basic understanding of network automation. and what commands does what. We will go through it for sure. You will need to know how to do a little bit of network automation for the exam. Okay. All right, guys. Thank you so much. Please take the time to work on the assignment and just email me once it's done. Okay. I'll have this LMS uploaded to the LMS in the next 2 to 3 hours for sure. Okay.
Okay, thank you very much,
Thank
Khalid,
you.
for
Thank
this
you.
class.
Thank you. Thank you.
Thank you, sir.
Thank you. Thank you. How wonderful day, guys. How wonderful day.